Welcome to lecture series on digital image processing. We'll be going ahead with today's class that is based on region-based segmentation. Uh, Basic outcome of today's lecture will be you will be having a better understanding of region-based segmentation. In that, you are going to study what is region growing, then region splitting and merging techniques. Let us go ahead with the content which we have covered in previous class, basically wherein we tried to understand what is thresholding in image segmentation. Okay. So there were three different classifications of segmentation that we had seen. One is intensity based segmentation, which is basically referred as a thresholding method. Second is edge based segmentation, and third one was region based segmentation. Anyway, today we'll be covering with region based segmentation. Since we are revising the previous class content, let us go ahead with the thresholding aspect first, then we'll come back to region based, then some points on edge based segmentation will be discussed. So there were some assumption that we had seen in what will happen in thresholding, isn't it? Two assumption we have made for thresholding aspect. One is regarding the intensity values. For a different region, you may have a different intensity values, isn't it? And the second assumption was regarding what will happen in a region. What assumption we have to do is might be the intensity values are similar in a particular region, isn't it? That is the second assumption that we are carrying out whenever we deal with the thresholding method. So one picture we had seen how the original image may get affected by varying the threshold, isn't it? So for threshold 50, how the picture was looking, and for 75, there may be a closer combination of those two components, isn't it? Might be sometimes a question arises how to decide this threshold value. So taking up a very low threshold value, even we cannot discriminate among images, and even if you select a threshold value very high also, there will be always an ambiguity, isn't it? So that need to be sorted out whenever we take up an threshold value related to an image analysis in image segmentation methods. Okay. That's why there are various thresholding methods to be that we have to follow whenever we carry out image segmentation. So one of the global thresholding method was studied yesterday, wherein how to decide for the value of a new image when we consider a particular threshold. Okay. For f of x comma y, whenever it is greater than threshold value, we have assumed it as 1, and all other values we consider it as a 0. Okay. That is part of global thresholding. So we are trying to understand here now what are the basics of intensity thresholding. So here I had discussed about two terminologies. One is called object point, and the second one I had discussed about background point. I hope you are remembering that. Okay. Any point which is x comma y point, normally we refer it as coordinate values, and we call it as x comma y in an image. At which, if you are considering that f of x comma y is greater than threshold value, then we call that point as object point. Otherwise, the point is called as background point. So something we can say when something referred with the representation 1 will be treated as object point, and when referred with 0 we can say that is falling under background point. Fine. So we had seen different types of thresholding. The one was variable thresholding, then second was local thresholding, one more adaptive thresholding, and multiple thresholding. These are different types of thresholding, starting with the global thresholding, what we had seen a generalized case. Isn't it? So whenever there is a change in T, we can categorize in the classification of variable thresholding. If at all your threshold depends on the neighboring pixel value of an image, where you are considering the center point x comma y value, then that may be considered as local or regional threshold. In adaptive thresholding, your thresholding is a function of x comma y. So what is the consideration that we had seen in multiple thresholding? We could classify threshold into more than one value. Might be two threshold we have considered for this example for the g of x comma y, wherein if you consider an image value f of x comma y with threshold greater than t2, you are considering it as a. Lying between t1 and t2, you are considering it as b, and less than equal to T1 we are considering with the value C. How this will be helpful in real life examples, because whatever study we are going to do in digital image processing in day-to-day life, those algorithms, those methods are implemented, and somehow we are trying to use them in most of the applications. Okay. So we'll see now how this is helpful in understanding some of the image analysis aspect. So before getting into the part of application wherein we are trying to understand how multiple thresholding is useful, we'll just have a look on some of the theory aspect, or how best you can define now thresholding, and on what basis it is going to be based, and what are the assumption that we have to do for the regions based on the thresholding. So if you see the segmentation methods, then we can consider thresholding is the simplest way to perform segmentation. And that's why in many image processing application, we are trying to use this particular method. Okay. So might be what is the indication, or what is the notion that thresholding is based on? So might be you are trying to collect those regions which are might be different regions you are going to classify in the image by using some range of functions applied to intensity values, or intensity values of image pixel. That is the second consideration we can have for thresholding. And assumption, as we have discussed, basic two assumptions are there, but generally when we think over this, see, assumption we have done with two different, might be you have different intensity values existing in image. Okay. And when we consider, might be there is a distribution of those intensity pixels will be there, but how like technically how we are going to segregate those intensity variation analysis, isn't it? So might be we use a term called like frequency distribution is there in the pixel values whenever there is a intensity variation is there. And to analyze that, we have to go for a method wherein we speak of statistical methods called as might be mean and standard deviation. If you are very attentive in the classes taken by the Lavanya Doluri madam, wherein like especially I'm talking about the add-on course where she has highlighted how to evaluate this mean and standard deviation for the probabilistic data. Same way in pixel in an image for the most of the analysis will go ahead with the mean and standard deviation aspects. Okay, so that is the assumption carried out for the thresholding, because we have to decide the thresholding value whenever we carry out some segmentation methods. Okay. So here is one example that I tried to insert for the discussion of thresholding analysis, how best we can do it in day-to-day life, or what are the application. If you think of an medical field, how this thresholding method is used. Fine. I think graph itself will give you an idea why we are categorizing like that. But still, let me discuss, because we are trying to understand what this histogram is going to represent, isn't it? So here, histogram of two-dimensional medical image is considered. Uh, so you are trying to define here might be depending on the threshold value. You want to know, you want to classify what is the bony or fatty tissues, or might be the muscles are there. In that case, you have to set for an image depending on the threshold some condition. You have to decide whether it is bony or fat or muscle is there. So what is the range here we are considering here? For if I of x comma y less than t naught, we are considering it as a fat, and greater than t1, we are considering it as bony. If it lies between these two threshold values, then we consider it as a muscle. Okay, so that's why, like we can say here somewhere what is that t1 and t2 assumption we are going to have. Just check here. Muscle threshold we have decided, and bone threshold. Based on that, we have like implementation of multiple thresholding aspects here. Here, the graph is related to frequency versus image intensity value. Okay. I hope the understanding regarding multiple thresholding uh, analysis in real life or medical field application is more clear to you, because yesterday only had given you idea how mathematically we can define multiple thresholding, and hope this example would have resolved your any ambiguity in understanding the multiple thresholding classification. Shall we go ahead? So yesterday we had discussed about either single threshold or dual threshold methods to be used in histogram, intensity histogram. But some of the factors we had seen that will affect the histogram might be the separation between peaks or noise content in the image, or the relative size of the objects, or might be the uniformity of the illumination and reflectance. So that may affect some of the histogram parameters. So we had seen how the noise in image will affect the thresholding aspect, because whenever there is no noise induced in an image, we had seen a clear cut spikes mode, two spikes mode visible for the given image. And if there is an inclusion of some percentage of noise in an image, might be that spikes gets widened, and still we have a quite separation existing between histograms, so we can even find out the depth of the valley between these two spikes. But if the noise level has increased, then the separation becomes very difficult, and additional processing should be done on the image, isn't it? So differentiating between the two modes of those image is difficult. That is how what we had seen yesterday regarding the role of noise in image threshold. Thing that we discussed was regarding illumination and reflectance on image thresholding. So what you are able to see from the picture? Yes, anybody? Do you remember what we have discussed regarding this slide, what I am representing, wherein histogram of noisy image and then intensity ramp and product of those two values was considered. Do you remember the discussion what we have discussed yesterday? See, we are trying to multiply a noisy image with intensity ramp. What will happen? Yes, anybody? Yes, Shri Raksha, do you remember the discussion? What will happen if you multiply an noisy image with intensity ramp in particular range? So if you see the histogram of the last part, that is wherein image is multiplied with intensity ramp. So the deep valley between peaks was corrupted, and the separation between two modes without additional processing is now no longer possible, isn't it? So that's why we always say that illumination and reflection part also affects the thresholding aspect. So we had seen a basic global thresholding algorithm. Why we use term global here? See, remember, whenever the intensity distribution of the object and background pixels they are sufficiently distinct, then it is possible to use a single or sometimes the same threshold application, what we are calling it as global, okay, over the entire image. But in most of the applications, what will happen is there is enough variability between images, even if global thresholding is a suitable approach. Okay. Uh, so in most application, what will happen? Enough variability between images will happen, so that we find that global thresholding is a suitable approach, wherein this particular algorithm is capable of estimating threshold value for each images required, because this particular algorithm, which is an iterative algorithm, can be used with uh, as we had seen yesterday, and in the algorithm also we are able to see it, how best we can represent, segment the image using a threshold with two different representation as G1 and G2. So initially you have to estimate what is the global threshold value T. Then you have to segment using that threshold. So there will be two groups, group 1 and group 2. You are trying to collect group 1 pixels for brighter than T, and then group 2 pixel for darker or equal to T. So then you have to evaluate the mean value for those groups. Okay. So we have considered it as here M1 and M2. Then compute the new threshold value, which is the average value of those two mean what we have obtained for the previous step, isn't it? Then you have to repeat this step till till the you work it out for difference between those t values. Every time t minus t new you have to find out, and whenever up to the value greater than delta t, you have to go back to the previous steps in evaluating the new t. Otherwise, you have to stop. So what it means, you are successively thresholding the input image and calculating the mean at each step. Okay, and might be you are trying to proceed. This procedure is helpful in expressing all the computation in terms of image histograms. Okay, so when to stop? That is a question. So that's why this parameter delta t is used to stop iterating when the changes in the threshold value is small. Okay, when we have changes in the value of threshold value is small, you can think of stopping this particular iteration. But how to choose a initial threshold? That is also a big question, isn't it? So most of the time, initial threshold must be chosen greater than the minimum and less than the maximum intensity value in the image. I think this part I have told even yesterday. I don't know how many of you are remembering, but how to choose the initial threshold value. It should be greater than the minimum and less than the maximum intensity value in the image. That is the condition. So one example we had seen related to fingerprint, how the histogram looks and segmented the image for the thin image border for the fingerprint was added through image segmentation. Here for this particular example, yesterday I did not discuss anything on threshold. Only I told that some thin image borders have been added for the original image when we segment using a global threshold, isn't it? So here threshold was considered as 125.4 value, threshold value, and after almost, like you can say, like roughly you can take it as 125.4 or 125 to segment the original image, and you can start with considering delta t as 0. Okay, so let us go ahead with today's class content, wherein we are trying to understand how the region based segmentation is carried out in digital image processing. Still one more method we have to cover in thresholding. We'll take up it later on. It might be the optimum global thresholding using what to choose method. Just I wanted to make an understanding because three segmentation methods I have listed initially. We will try to have an understanding first, then we'll try to go for some algorithms that we have to discuss either in thresholding or segmentation, right? Thresholding also part of image segmentation only, but the discussion what we are trying to have on region based segmentation and thresholding aspect what we have dealt previously, those are all part of segmentation methods, fine. But there is a still kind of difference exist between the discussion. Okay, so just check, like when we attempt to find some boundaries between regions based on the discontinuity in intensity level. Okay, that was the discussion what we have carried out very first. Am I right? When we started with the image segmentation, we could find the boundaries between different regions based on the discontinuity of the intensity levels. Then, like how we tried to accomplish it, isn't it? So that we could do it through threshold. we could know, we were aware that the image was consisting different intensity levels. How to handle that? For that, we went for a method, might be a thresholding, one method wherein we are trying to, based on the distribution of the pixel property, might be intensity value or color, we are trying to segregate that part. But what is the discussion that we are trying to do for today's class? That is image segmentation, wherein probably I'm trying to discuss more on uh, region growing or region based segmentation, wherein region growing or region merging or region splitting we are trying to understand. So here the segmentation techniques are, we are trying to find the region directly. Okay, we are trying to find the regions in an image directly through these methods. Okay, so how to group a similar component, isn't it? How to group a similar component? Most of the time, whenever we want to group something, we always go for an one aspect where we try to find out some similarity, isn't it? So see, it is applicable in even in day-to-day life. Whenever you want to have a friendship, you will try to find out whether your nature matches with somebody else, isn't it? So might be like similar components we are trying to hunt in a grouping. Okay, might be see what kind of component we have an image, a pixels in an image, and when we go for a video or some kind, we think of similar frames. Okay, image frames, isn't it? So to obtain compact representation, so that is how we are thinking, isn't it? So when we see the image segmentation applications, some of them have listed, they are not limited to this, wherein I think you can, where you can remember the things and identify those application I have highlighted. Might be finding some tumors, veins in medical images. We can find the image segmentation application. When we go for either satellite and aerial images, we can think of identifying different targets. If you consider some surveillance images, you can think of finding people in a particular image. Okay, so that is how the image segmentation helps each and everybody to analyze different things available on those pictures. So we are trying to understand what is region growing based segmentation. Okay, so one thing you remember, uh, when we are trying to go for an region growing based segmentation, we hunt for this parameter which is called as homogeneity. Okay, so homogeneity of regions is used as the main segmentation criteria in region growing. See, when that grow term itself will give an idea, you are talking about something, you are starting from the minimum and you are trying to grow in a broader way. You want to enlarge something. Okay, but the region growing itself is giving an idea what should be done and how it should be done. So that grow word itself is give you some conclusion over the method. Okay, so might be when I say you have to go for an homogeneity of the regions, you have to think on certain parameters or criteria. Might be you're talking about gray level, color, texture, shape, model. Okay, you are trying to pick up those words for your homogeneity aspects. Just check here. So what is the purpose of region growing? Might be you are segmenting an entire image R into smaller images with some conditions you are trying to meet, because whenever you unite those regions, you will get a main image, isn't it? That is what we had seen even in a discussion wherein we have discussed how a region should satisfy several conditions. 5 different conditions we had seen about the regions, isn't it? So how to understand now this region growing? Okay, so it is a procedure. It is a procedure might be that groups pixels or subregions into a larger region. That is an indication for the region growing. And most of the time it is considered with a pixel aggregation. So what is the meaning of pixel aggregation? Okay. So you have to start with one single point, or we can call it as a seed point. From there, you have to grow your region by appending those each seed point. Okay, that means you have to consider the what are the different neighboring pixels that may have a similar property as where you are considering the seed point. Okay. So when you consider the similar property means you are talking about a gray level, texture, color, shape. Okay. So that is what I have listed those in homogeneity, or you are trying to find out a neighboring pixel which may have similar properties. Okay. So that's why most of the time the region growing based techniques are considered more better as compared to edge based techniques. Though we have not discussed edge based, anyway we'll discuss it later on. But right now you remember how it will be better, we'll come to know, because soon in the last slide I have tried my level best to add that edge based technique details in a short way. Right now, region-based technique is considered as more better compared to other techniques. Okay. I hope this picture itself will give an idea of what we are trying to understand through region growing. Okay. The very basic pixel, the point where you are trying to take, it is considered as a seed point or seed pixel, and the arrow here indicates the direction of the growth. So growing process after some iteration, how it may look, that is what we are able to see in a second picture. Okay. Now selecting a set of one or more starting point. Okay. Where exactly you have to start that, how it should be proceeded. That is the nature of a problem that we may come across, isn't it? So normally whenever we consider a pixel, as I said, same set of properties are used to assign pixel to region during the growing process. That is a normal method adopted. And if while doing such a analysis or such thing, if the result of the computations shows some clusters of values, isn't it? Then pixel whose properties they place a near centroid feature will be considered, because there is a possibility that when you are searching for a neighboring pixel, uh, they may have a lot of similarity and there is a group of pixels existing. Which one to choose? That is a biggest problem in any selection of the similarity criteria. So that's why some other consideration also we have to take up, isn't it? That's why the selection of similarity criteria depends not only on the problem under consideration, but it also depends on the type of image data available. Because see, for example, if you take some land use satellite imagery, which basically depends on the use of the color. Okay, so then there we have to solve this problem through some might be other analysis also, might be you have to go for an images of monochrome or region analysis you have to do. Okay. So some kind of extra computation is required whenever we go ahead with some grouping pixels with the same intensity value to form a region. Might be we are not paying any attention to the connectivity. Might be we are only interested in finding what is the similarity existing for the pixel. Fine. So we'll see some rules. Before that, the rules have listed here. We'll come back to that. Before that, we'll just see this picture and we'll try to analyze some things. Then again, I'll come back to those rules. So right now, just have a glance on this different images presented. One is X-ray image of defective weld. Second representation is for the histogram. Third is you are considering initial seed image. Okay. Then this image is final seed image. Absolute value of the difference between seed value. Seed value was considered here as 255. Then again histogram of this particular image. Okay, in the previous picture. Then we have a difference image threshold using dual thresholds. This image is difference image threshold with smallest of dual thresholds. And lastly, we have segmentation result used through region growing. Okay. So this image is collected from X-Tech Systems Limited. Okay. So we'll see now what it means to us. Please see here. You have an 8-bit X-ray image of weld, which is horizontal dark region. Okay, you have an horizontal dark region containing several cracks and porosities. That means you are trying to have an bright regions running horizontally through the center of the image. Okay, you are having some bright regions running horizontally through the center of the image. Even in yesterday's discussion, I had given you one hint how to differentiate between different intensities. Of course, that is based on the threshold. Am I right? So we have to consider. We have to first find out or we have to determine what is the seed point, isn't it? We have to find out what is the seed point. Okay. To do that, of course, we should know what is the threshold and all. But still, what is the general observation we can do for this is if the absolute difference between the intensity between the seed and the pixel which is existing at any point, if it is less than some particular threshold value, you consider the value as true, otherwise you consider the value as false. So you are trying to implement this analysis with again a concept of a thresholding method only. Fine. So that is one thing. So wherein we are able to do like what threshold we have to choose. That is one consideration that we have to remember here. Second thing regarding the dual threshold, though we have not seen here what is the value, I think the graph itself has represented the idea difference image threshold was taken with the dual threshold. For the given figure, the threshold T1 was 68 and for the second level that is T2 was 126 value was considered. Okay. So that was taken according to the closest value of the histogram of the previous. Okay. So if you observe this first histogram of that image, you have value as 0, 63, 127, 191 and 255. And that's why T1 was taken as almost 68 and T2 was 126. Fine. So seed values, as I said, it was considered as 255 because image was thresholded with a threshold of 254. Okay. So second one more example have represented here how region growing may help you to understand things related to image in a better way. Okay, just check here. Seed point I is equal to 255. A small line might be you are not able to view it, that you can see in original image. Okay, the moment you put a threshold with might be some value with that minus 255, you are able to see that clear indication of that. Let me just put back. Yes, just check here. Then see the difference, how we are able to see 155 minus 255, how it has enlarged, and the previous value was related to 190 minus 255. Means how the thresholding is helping us to understand the region growing problems. Okay, so that's why we always say that whenever we go for an region growing algorithm based on some connectivity, that is particularly 8 connectivity, we have some rules. Okay, we have some rules that should be followed. So we have set of 4 rules here. First, you have to find all the connected components in S of x comma y to reduce each connected components to 1 pixel. Okay, you have to label such pixels which are found as 1, and all other pixels in S are labeled as 0. That is the first condition. Then you have to form an image, a new image, which is F2. Okay, so how we are stating that new image point uh, based on again value of 1 and 0. So fq of x comma y is considered 1 if the input image satisfies the given predicate value, and q at this point is considered 0 otherwise. If it doesn't satisfy the particular condition, we consider it as a 0. Okay, so your G will be considered as a new image formed by appending that seed point of S. So all the one valid points in FQ are it connected to that seed point. That is the third, we can say, third thing that you have to follow. Then you have to label each connected components of the G with the different region labels, might be with some integers or letters. So this is a segmented image obtained by region growing. So this is a rule for the, this rule is followed for region growing for 8 connectivity, based on 8 connectivity. Okay. Here, when we consider f of xy, we are talking about an input image. Okay, and when we consider s of x comma y, we are considering it as a seed array containing ones at the location of the seed point. Otherwise, we have to consider it as 0. So here Q is considered as a predicate to be applied to the each location of x comma y. So we'll go ahead with understanding the term region splitting. Okay. So in the previous discussion, we had discussed about region growing, and the very best example that I had taken wherein a seed point was grown, isn't it? So region growing normally starts from a set of seed points and you try to occupy the entire image. Okay, what may be the alternative if you think of an whole image and might be considering with the single region or subdivision of the regions. Okay, so that's why alternative is to start with the whole image as a single region and subdivide that regions that do not satisfy a condition of homogeneity. Means we cannot expect every time in an image, the homogeneity aspect will be everywhere, isn't it? So in a situation wherein might be it is not satisfying the condition of homogeneity, we have to go for some other things. So that's why the region splitting helps us to subdivide the image into different regions. Just have an look over the given uh, image here. Okay, just we have partitioned, am I right? We have partitioned into R1, R2, R3 and R4. The very first, if you see this, we would have done some 4 region division, but we are able to see in the fourth subdivision again a partition. What is that? Might be R4 1, R4 2, R4 3 and R4 4. What you are trying to, how we are trying to justify, how to evaluate these partitions, might be on what conditions, because here some new terms will come that you have to understand first. Okay, one is regarding the quad regions. Okay, quad regions or quad images, or sometimes we call it as a quad tree. Okay, so when we represent in terms of some uh, form, conventional representation, when we are using, we may call it as quad tree. Okay, and when we represent it as images corresponding to this form, we may call them as quad regions and or quad images. Fine. So what we are able to see here, an image R is divided into some 4 regions, and then fourth region is again divided into some 4 partitions. Okay. Then how to summarize this procedure? We are splitting into 4 disjoint quadrant of any region Ri, isn't it? Any region Ri, because R1, R2, R3. I mean, you don't know, might be you are thinking that all those regions are disjoint and Ri. But that means whenever Q of Ri is considered, if it is false, then we consider those regions as disjoint with the region Ri. Second thing, what we have to consider for the algorithm is uh, when there is no further splitting possible, you have to merge any adjacent region Rj and Rk, for which Rj and Rk will be union. Okay, and the value is true. That is the second summary what we have for the procedure. Okay, I have not listed it, just I'm trying to tell you, and we'll try to even understand more better way. Then you have to stop when no further merging is possible. Okay, and most of the time we do this analysis again depending on threshold value. Might we think that in R1 you had some pixel value 2, 3, 7, 6, 5, something like that. Then R2 you may have 7, 4, 3, 2, 1, like that. Then you have to find out what is the maximum value and minimum value existing in each region. Find out a threshold, compare it with both the regions. If it is almost trying to give a similar value, you can merge them. Otherwise, you can split them. Or if it is not satisfying the threshold value, just again partition with some other condition. That is how we do this partitioning or splitting of those regions. Right? We'll take up one example related to that later on. So right now, remember how we are able to do this partition. So here R represent entire image region, and you have to select a predicate Q. So one approach for segmenting this R, okay, one approach for segmenting this R is to subdivide it successively into smaller quadrant. So what is the condition you are trying to use? Your Q of Ri should be true. Okay. If Q of Ri is false, again you have to divide the image into quadrants. That is the condition. So what we'll do in image, that is region merging in image segmentation. Just now we had seen splitting. Obviously, the region merging is the opposite of region splitting. You have to start with the small regions, might be 2 into 2 or 4 into 4 regions, and merge them. And those regions should have a similar characteristics in terms of color, gray level, or variance. Okay, so that's why we normally use both this splitting and merging approaches iteratively in image segmentation. One simple representation I have taken what may be for original image, and if you have a split and merge procedure, how the image look like, and what is the thresholding effect will be there on the image. So some of the conclusions I have listed for your understanding, though we have not taken this part we have discussed, but still we'll see what best comparison we can give between edge based and region based. Here, when we consider for edge based segmentation methods, we are considering different objects separated by the edges. Okay, that means we are hunting for the discontinuity, whereas here different objects are separated by a kind of perceptual boundaries. What do you mean by that? You are trying to understand what is the neighborhood features. Okay, as I have already listed what are the different neighborhood features, might be intensity, color, then we had seen variance, all that. But in most of the image analysis, might be we are considering texture based aspect, though we have not taken up right now. We can take that texture analysis in images. Okay? So that is one thing. Through stochastic process, it is analyzed in region based. Then here in edge based segmentation is performed by identifying gray level. Here we are going to analyze it through some process. Okay. So this can be extended to color channels. When region based features are used, we have to define the different classes. Okay, might be we call it as clustering methods or something like that. So one more, how to compare counter based and region based aspect. So as I said, discontinuity property you have to check here. Here you are checking for similarity and homogeneity. And that's why we are having three different approaches. One is region growing, region splitting and merging. Then the last one is clustering, had to be covered. And thresholding, which already we have learned thresholding method. Here we are discussing about that isolated point, lines, edges. That's why I told you the entire image segmentation chapter, which covers from the edge-based techniques to the region-based techniques, as well as what are the different thresholding methods that we have to study. Fine. So what we can conclude from today's class? So one is regarding region growing, wherein you have to consider a pixel or sub-regions which are grown into larger regions based on some criteria. When we go for region splitting, we begin from a whole image and we try to divide into sub-regions. And merging must start from uniform seed region. I hope the things are very clear. Thank you. If you have any doubts, do ask on this platform.